mining, the class, and also the data mining technique, any algorithm. So definitely, we first understand what is the data itself. Okay, without understanding data itself, so it doesn't make sense. Even though you understand what is the clustering algorithm, what is the classification algorithm, it doesn't make sense to use such a data mining technique or algorithm. So in this chapter, we will see what is the characteristic of the data, what kind of the data type we have. Okay. But now it is true. Nowadays, it's getting more complicated. So sometimes it requires the domain-specific knowledge to define and to use such a data itself. So this chapter we will discuss about what is the data object. Sometimes it's called the data object in the data mining, but it can be viewed different way. But anyway, we will see such a data object and attribute of the data, and that describes the data object itself. Sometimes, if you can define clearly your data object from the data set, it's a half of them are already done. Even more than half of them are already done if you can clearly define such a data object. So for example, actually applying data mining technique to the multimedia data, such as a video. It's very hard to define what is the data object in video data. Even how can we describe such a video data using attribute? What kind of attribute we can use? So if we can successfully define such an attribute and the data item in video database, so I think the 80%, 90% already done. So such a data mining technique is just minor. So just like that, defining data set and data object and also attribute is very important. So also nowadays we already talk about something, the statistical approach already. And nowadays data visualization is not part of the data itself. This can be considered as another way of data mining nowadays. This is very, very important, data visualization. Sometimes without applying any data mining techniques, from the visualized data, you can see the answer. You can find valuable information from the visualized data. We will see a couple of examples today from such as the Google Visualize and Google Viz and some others. Okay. And also, needless to say, the data similarity or dissimilarity is also very important. So we are very familiar with the Euclidean distance. It cannot be applied to the general case. So we will see the importance of such a similarity and dissimilarity to understand the data. So what is the data? So this is the data set, but in the traditional concept of the data and the database, the data can be viewed as a set of records, set of the tuple. Each record consists of the number of attributes or the number of columns. So by defining such a column, we can define such a data item like this way, table style. So think about your relational model. Relational model, you define a number of the relation entity type. Each entity type consists of a number of attributes. So eventually such an attribute will be column, and each relation, each data record, and each the table, and each such a relation will be table eventually in the relational database model. That's just one example of the data type. However, in real life, in our real life, the data set is much more than that, and also much more complicated. So, but sometimes such a simple approach to relational database model can be used in our data analysis if we can do. Okay, but in general case, we need to think about the different data types that include. So we can classify into different ways, but it can be viewed as a group of records So like the document data. Document data can be viewed as a number of words, so frequent word. Okay, this approach is used for Google search or any web search. So each page the Google and the Yahoo or Bing, they crawl, they visit each. Every time they visit the new website or the existing website, web page, then copy. And they find such a frequent word for faster search, something like that. So we can view as such a document data as a number of the frequent words. That's one way. There might be different way also. So as I said, depending on how to define such a data item, it can be totally different approach. Okay. Also nowadays, the graph and the network-based the data that are very popular, such as the social media data, such as Facebook and Twitter and Flickr and whatever that is based on the friendship or the connection, so it can be easily represented by a graph. So that is a graph or network-based, World Wide Web, social network or the information network, and so on. Even it can be applied to the others, okay? Not only just the social media data, but others, the data set. And sometimes we have the ordered or time-based. Time-based ordered, so such as the video data. Video data, what is a video? It's a sequence of images. They are aligned by the time. Okay, then we can see moving picture. So it can be viewed as a same kind of a time series ordered data, such as a video and sequence of images. Also time series data like the stock market price. Stock market price, so along the time we have the price. So 9 a.m. to 3 p.m. So price is going up and down and something like that. So this price is called the time series data. Time series data is also very important nowadays to be analyzed. Okay. Also sequential data like the log data. Every time it's not periodically, but keep generating the log data along the time. So we can analyze such a sequential data based on the ordered data. And also spatial information, GIS information, or X and Y coordinate, such as image. Image consists of a number of pixels. So each pixel represents R, G, B values. Okay, then finally we can see something picture or photo like this one. That means it can be represented as the two-dimensional images. So this is called the spatial image data, spatial data. Okay, so image data, also video data can be viewed as such a spatial information. So video data is kind of a spatial temporal data. So that was one of the reasons I select the video data for mining for my PhD dissertation. So it's not just the spatial data, it's not just time series data, it combined. Even that include audio data, audio information. The most challenging at the time, not many people apply the data mining technique to the video data. Okay. If you search the video data mining, actually my supervisor, his name was the first one sometimes. I don't know nowadays, I didn't do that. Okay. So we have such a transactional data. This is an example of the transaction. For each transaction, like the one customer purchased this item is a transaction ID 1 and so on. So can we find something pattern out of this? So this is the first step, whether you understand your data set itself. Without data set, can we apply the data mining? Nowhere to apply. So data is the first one. That is a characteristic of the data mining. That's different from the machine learning and other artificial intelligence AI class. So data mining, we are focusing on such a data set and data item. So the first step is whether you can define such a data item. What is my data? Okay. To do that, we will define. In data mining, we can say the data object. Sometimes we can say data item. It doesn't matter. Okay, it's the same meaning but different way. So sometimes it's called the data object, or sometimes the data item. In the relational model, it's called the relation or table. It's the same concept. And each data object can be called as the sample, example, instance, data point, or object tuple. All of them are the same thing. Okay? So, but many of the textbooks use the data object, or data item, or data instance. Point looks like the certain coordinate value, but you can use the point also. Okay. Also, each data object, sample, whatever, they should be described by the attribute. Okay. In terms of the relational model, it's called column or attribute. We use the attribute also. It's the same thing. So only just one attribute? No, it's number of attributes. That's also challenging. It's not easy. For example, I decide the data item as a Facebook user. That's okay? How can we define the Facebook user? What information you are going to use? Okay. User profile information, that's not the only. That's obvious. And also the number of friendship and what the friendship level and what information you are going to. Sometimes it's obvious, sometimes you cannot find. Even defining attribute is challenging, and it's also you need something data mining techniques to be applied. So that attribute is very, very important to identify. Okay? If you can successfully done the identifying the data item, data object with the corresponding attribute, half of them are already done. Okay? So in same meaning. So attribute, sometimes it's called the dimension or feature. Mostly the image processing or video processing, they try to use the feature instead of attribute, but it's the same meaning. Variable, in statistics, we call the variable, especially random variable that we discussed. Okay? Or sometimes the dimension, the data. Then this attribute describe the data item, data object. Okay? For example, customer ID, name, address, describe the customer. Something like that. And it has a different types of attribute. It's not like the data types used in the programming language. Okay, it's kind of characteristic, but when you implement this attribute in your programming language, if you can find the existing data type, you can use it. Otherwise, you need to define in your program. Okay, so when you implement it, so there are different types of the attributes. First, nominal data. What is a nominal data? It's for example, hair, black, white, yellow, blonde. It's a nominal data. Okay, there's no specific order. There's no specific weight. Just the type of the data. That's the nominal data. And also binary data. It's either 0 or 1, or man and woman, something like that. But in case of the man and woman, it's a half and half roughly, right? So that is a symmetric binary. But sometimes, for example, the cancer. So positive, cancer and the normal, it's not half and half. It's a cancer or positive case is a very, very rare, 0.1, something like that. That is a symmetric binary. So, for example, I'd like to classify from the Facebook user, we have this is one of the challenging research. Can we identify, when we see the Facebook page, can we decide whether this user is a man or woman? Okay? So, my program, I have the algorithm, whatever that is, I can find 60% accuracy. Do you think it's reasonable? Even random guess is 50% in binary problem. So you should be careful when you evaluate. Also, for example, the HIV. So I'd like to find the positive, okay, HIV, not using test, but using other information. Can you find? So let's say the HIV case, positive case of 0.1%, okay? 99% are negative, it's normal. But only 1% is HIV, so positive case. So my program, so when I tested the 50 patients, so all of them are negative. Can I say, so one of, but actually there is only one HIV positive. So I tested 100, only one of them are real the positive case, but my program, yes, the all negative, which means 99% accuracy. Can I say? Because anyway, 99 out of 100 are correct. So you should be careful when you deal with the binary data. We will see how to evaluate such a case. We can consider, for example, precision. How much precise, okay, our algorithm is. Or the recall, how much recall correctly. Also, such the medical test is very, very critical for false negative, false positive case. Okay, positive should be returned correctly always. So we will see such a thing later. So that is from the binary. Ordinal means it has the order. Okay, like the small, medium, large. However, don't be confused with the number. Even though it's order, we cannot say small plus medium is large. Right? So there's no sense of each word, but it has the order on it. That is the ordinal data. It's kind of a ranking, so you can understand as just a ranking. Okay. And finally, we have the numeric, the attribute numeric data. So there are two types of the numeric data. This numeric data is different from ordinal data. Okay. Numeric data definitely ordinal data, but each value has the meaning. Like the 1 degree plus 1 degree is the 2 degrees. Okay, it has the triangular inequality. Okay? However, some of the data are based on the certain base point, like the 0 point. Okay? But the others are not. For example, the temperature. 0 degree in Celsius and Fahrenheit, any meaning? No, it's just a relative. Okay, the 0 is a freezing point, but in Fahrenheit it's a 32 degree. Okay, so there's no specific meaning. There's no 0 point. There is no basis. It's just relative. However, some of the data like the Kelvin, the temperature, so 0 means it's something base. From the 0, it has the value. Or something length. Length means when I say the 5 inch of this width, 5 inches from the nothing 0. Okay? It has a 5 inches. So that is the ratio from the 0 point, certain basis. Okay? So we can classify the data and the attribute of the data as discrete and continuous. Everybody understand what is the discrete? You are familiar with the discrete value because we are in the discrete computing. the computer can understand discrete data, okay? But nowadays, even the continuous bit are used, like the temperature and the height. Sometimes we can imply the continuous data from discrete data using something smoothing technique, okay? Make the such a continuous attribute. Okay, that is the type of the data that we are going to deal with throughout the semester. Okay, so we already talked about the such a basics, that is correct description of the data. So I'm going to quickly move. Right. This is one of the ways central tendency or variation and the spread out to understand the data set itself, such as the mean value or variance or covariance or the standard deviation, because it's the one of the naive way, the easy way to describe your data. So if we can successfully describe the data, which means we can use such a data. So that is the central tendency, like the mean value, and also there are other statistical functions that we can describe the mean value or maximum. Okay, and what is the median? The middle value. Median is make the order. For example, we have the two data set, like this one, almost the same, but only one difference. However, if we are using the mean value, this is a 3, this is 5, this is 110 divided by 5, is 22. Huge difference. Okay? So this can be considered kind of noise, the outlier, the extreme case. They are quite similar. So to address that one, we can use the median. Median value is a 3. And also median value is 3. So that is the median can actually minimize, reduce such an extreme case. So not always the average. Average tends to bias such an extreme value. So at the time you can use other statistical function to represent, to describe your data. So that is, and also we test quantile. We will see the example of the quantile and outlier and variance later. Okay. And also, so this is the central tendency function. So mean, I think everybody understand such a mean. It's average measure, so divided by number of, okay? And median is the middle value, okay? Median can be represented by this one. Not easy in terms of the computation. It's much more complicated than expensive than the mean value. And mode is the frequency, most the frequency value. For example, if we have the one here, this one is the first one. It depends on the frequency. But from the empirical result, you can say the mean minus mode is 3 times of the mean minus median. Not always the empirical result. Okay, roughly, any data set can be represented this one, which means even though we do not know the median, we can actually guess such a median value. Vice versa. Okay. Then our data set is not always the symmetric like the Gaussian distribution. Sometimes it's a skewed data. Okay. So like the Poisson, the distribution. Okay. Or it's a negative skewed data. This is you can see that this kind of thing, arrival weight. Okay, so arrival weight. So I think in your discrete math or the statistics, I'm not sure where you can run, which Poisson distribution is skewed to left. or exponential. Other way to represent your data is using the quantile. Okay, quantile is divided by the 4 your data. First 25% of the data, next 25, which means the half, then the 3/4. So you can use the 3 quantile, or sometimes you can use the 3/4 minus the 1/4. That is the IQR into quantile range. I never used. I learned only from the textbook. And but this one is frequently used, the 5-number summary. That is the one way to describe the data using minima, maximum, median, Q1, and Q3. So for example, I have the something result, but it's not always a fixed result. So whenever I test it, it is a little bit variance. So I'd like to show such a variance of the result. At the time, you can use what is the minimum, what is the maximum, and what is the median, and also what is the first quantile and the third quantile using this. So we will see the example of such the 5-number summary, and also the outlier. Okay, if that is the sometimes outlier is a very subjective. What is the extreme case? What is the outlier? But usually, as we can say, usually is considered as the higher or lower than 1.5 of IQR, which I never used. Not many research paper are using this technique, but it can be considered. And also variance, how much is spread out from the mean value center. So we will see the example. There is a Boxplot analysis. We can use the lower and the upper and the quantile, first quantile, third quantile, and median. So we can represent the range of the data using this one. Then everybody can believe that this is a little bit skewed to the right, and mostly here the median value here, but it has a very low value, minimum value, and maximum value. So when you have the variance of the result, you can use such a box plot. So I think that you have seen this kind of the result from the even not engineering paper, but art and science, the psychology, they use such a box plot data to represent the result. Okay. And this is another example of the box plot in 3D. Okay. We have the 1, 2, 3 value. This one is the profit, this is the revenue, and this is the cost. So you can see some wide range of this one. So in case the revenue is the 5,000 to 500, 5,500. Also, is the cost of revenue at the cost of 1,000 to 2,000. It has variance, something like that. We can understand that's such a characteristic of our data set. And this is the example of the normal distribution. Normal distribution, we can actually, because it's a median is the median, the average is 0. It can it is adjusted to the average is 0. We can consider how much distribute. So this is 68%, and mostly 95%. And 99.7%, something like that. Using that normal distribution, actually we can guess, okay, based on the poll or based on the sampling, we can guess how much accurate. Okay, this one. So that is the reason whenever we have the presidential campaign, the margin is plus minus 3%, something like that. Even though they ask the question to the only 1,000 people, so accuracy is the plus minus 2.5. So using such a normal distribution. So there are different ways to represent our data set. The first one is a histogram analysis. The histogram is a kind of the frequency. Okay. So using that frequency, for example, 1000, it has this amount of the value and value. So we can see the probably this is the major part. Okay. Also we can imagine something kind of the distribution, even though this is from the discrete value. So we can see overview of the data set, distribution of the data in your data set. But sometimes the histogram cannot be applied. Extreme case, for example, we can use such a histogram for image data analysis. We have the 2x2 images. It has only black and white. This is black, this is white, this is black, this is black, this is white. Totally different image, right? A histogram, black, white. Both of them are the same. So you should be careful. So when you are using such a frequency or the histogram analysis, it shows only the overview, overall distribution. It doesn't show the characteristic of them. At that time, you need to consider some special data analysis. And that is the histogram scale. It's very popular. You can use the histogram analysis to understand your data. Also, you can apply the histogram analysis to the box plot. So, what is the quantile? What is the half? What is the third quarter of the data? Okay. And this one shows the some. In case you have the one value, this is the first, you need to sort the data, okay, then scale to the 0 to 1, okay, you can scale up. Then point that to the price. So then you can see it's a monotonic increased one, matched one, you can see what is the, so it's a data item. Data item, but it's ordered by the price. Ordered by the price, then plot. This, then we can easily see the 25% is the $60, and the half median is the $80, and the maximum is the $100, something like that. That's the one way to understand the data using the quantile plot. If we have the two variable, okay, like the unit price in branch 1 and branch 2, we can rearrange it, such an item by the price and compare. Okay, so then we can see this one a little bit going up, so which means this price of range, like the 70 to 100, the branch 2 is a little bit expensive than branch 1, which is not easy when we have the just price of the branch 1 and branch 2, whether who is more expensive than other. But using such a quantile to quantile the plot, we can, the others are it's kind of the covariance, so we can find this, but slightly the hum, which means this range, branch 2 is expensive than branch 1. You can easily identify such a characteristic. And just the price by price, there's no covariance we can find over here. So price and item sort. So if we can find this kind of for the two variable, this kind of arrangement, we can say this is correlated. Okay? And this one may not. And this is kind of negative correlated. Okay? Lower value of the x, the higher value in y. Okay? But this also can be considered as the correlated. And they are definitely uncorrelated data. Okay? This is just a randomly scattered. This is uniform and uniform with this. So nowadays, as I said, the data visualization is very important. I think this semester we are going to spend 3 weeks I guess 3 weeks to learn about the R programming. So using R programming, we try to analyze the data. At that time, you will cover a little bit about the data visualization also using the R program. One of the benefit of using R program is the data visualization. Very, very popular and easy. Okay, so benefit of using such a data visualization is easily get the insight of the data. Sometimes from the number, not easy, what's the characteristic of my data, and what is the problem, what is the outlier, what is the, it's very hard to understand. However, if we just plot like this one, histogram, or histogram one of the data visualization, then we can see it's half and half. Okay, equally distributed, or the something, the peak and something, the hump, so we can get the insight of the data. Okay, and also definitely we can see the overview of the large data set, which is not easy when we have the millions of data, but if we make the something visualize the data, we can easily understand such a data. So we will see some of the example from that. Okay, and also very, not very, but easy to search such pattern or structure of the data. Even though we do not apply the specific data mining technique, we can find from the visual information, we can find such a pattern of the data. Okay? So, and also to define such a visualization technique help the user to define the problem or data set or attribute. Okay? So let me show you one of the example of the Google list. I think I showed this one before in other class also. Those who this is a Google list. I think I do better use Chrome. This is a Google motion chart. So I will show you some example. This is an example of the motion chart. Okay, from the World Bank. You heard about the World Bank? So I don't know much about the World Bank, but they actually lend the money to the nation or country, and also they also collect the survey, the information about each country. So this is the, you can see the from the 1960 to the current information about something, the region of the data. You can see the yellow part is a South Asian country, and this one is Latin America, and the East Asia. I think the East Asia means it's China. So it's and also you can select a specific country over here, but I will select the default. And the size is a population. Definitely this one is the China, right? And yellow part, North America is the United States, and there fertility rate and the life expectancy, there are a lot of variables. However, if we, you can see, along the time, you will see the life, the expectancy is higher and higher, move to right. Okay? You can change it. You can see such a change of the data along the time, which is not easy from just the spreadsheet, right? There might be someone who can understand such a thing, but mostly it's not easy. But from such a motion, the chart, we can easily. Also, you can select specific country. So Bahamas. Let's see the China. China is here. As I said, it shows the more the details and information about the population as well as the mortality rate. And this is something is ordered by the mortality rate. Okay, and this is a min-max, minimum and maximum value, so we can see. So this is one of the just example of the Google Vis and the visualization tool. There are more examples actually possible. So motion chart is one of the examples. And GeoMap, this is using the map, okay? Then we can represent the data. You have seen a lot nowadays from the media or the news. There's such an example. This is an example. So how can we use using the Google script? So after you create the developer account, I think that you need to do something authentication there. It's just a script. In your code, you can just add this one. And treatment. I don't know why. Maybe disconnected. Not sure. Okay, so why don't you try? So at your home, get this one, so you may get the more idea about such a visualization. Okay, there are different ways of the visualization. So we can use the idea of the image. Okay, then each one represents a certain intensity value. Then you can make the images that can going up. The higher value means white, right? Lower means black. So you can see such a difference using pixel. And also we can use the circle. It's a different sector or different dimension, and sometimes it's a skewed and like that. Okay. And this is from the mechanical engineering, right? Like the kind of the kind of aerodynamics, I'm not sure. So we can use such a data directly to visualize information. Okay. Also, this is another visualization tool, scattered the matrix. So we can, each one has something different attribute. Okay, then represent the correlation. And this is the kind of, for example, the mapping to the landscape, like the temperature of the specific location. So we can use such a thing. And parallel coordinate, so which means that each one is data item. So whether this is up and down, and sometimes they are it's a different attribute. So attribute 2 is not much the differentiate, but the attribute 1 is differentiate. So we can use select this attribute to differentiate such a data item. Okay. And this is more data in real example. Okay. Also, it is true, we can use even the icon to visualize the data using the to represent the feeling. So if we are implementing something, the kind of emotion, not emotion. What is the name of the research to sentimental analysis? Like nowadays, sentimental analysis is very popular in the social media data. Whether, for example, IBM has good reputation or not. Okay, so if something happen in the U.S. government, their reputation is going lower. So we can represent such a trend using the icon. What are they? It's from census data, right? There. So income and age, and we'd like to see such a the relationship. But I don't know how to see. But each data is income. Along the income is age, which means
it says young people with high income don't seek relationship.
but what about each one? Is this something meaningful? I guess it's something meaningful. Okay. It's a very popular word cloud. So the most frequent word is bigger and smaller, so you can see the trend of that. I have used this one for the faculty research day, so several years ago, so you can see the education and engineering simulation and study, something like that, from the abstract. So I combine all the abstract and run this one. If you go to the word cloud the website, you can actually create your own word cloud. So we can use the hierarchical approach to visualize that. So dimensional sticking from the one dimension to next dimension and next dimension. Or one of the popular way of such a hierarchical visualization is a tree. The tree is the easiest way to represent the complicated relationship. So we can use such a thing. Okay. So each one. For example, this one represents something details of attribute 3 and attribute 4 inside attribute 1, attribute 2. So we can represent actually the four attributes using the two-dimensional data. But this small part represents the attribute 3, attribute 4, like this way. So you can see overall the distribution of the data, so they a lot of data over here, and also we can see something parallel for the inner attribute. This one is also public. There are a bunch of tools from your data, so to build such a graph or visualizing data. I will show you some of the examples. Also, this is the tree map for data set. You can see tree map, large data set. So using such information, actually you can design even your chip. So I surprised the last just before the winter break, I attended the conference. Then in that conference, I met one of my old friends. So after 30 years later, so actually we met each other. He is from IBM. He designed the chip. Actually, the idea is how to integrate the IC into the chip to design the IBM power chip. Then recently he moved to the energy department. What he's doing is he designed the energy grid, power grid for the city. Because he focused on when he designed the chip, he focused on how to reduce the energy consumption. It can be applied to the city architecture. At that time, he said that he used such a map, tree map. How much consumption are used for this part, from the chip, how much. So it can be represented by the color. So it can sometimes separate the part which I don't know exactly, but he said he is using this kind of map to when he designed the power chip. Then he applied this technique to design the power grid for the city. So at the time said he used a lot such a visualization, data visualization to distribute something part of the chip and certain to design the if the UV consume a lot of energy, then put the more the energy source like the power grid or the separate like this. I don't use this kind of thing a lot. And sometimes using such a non-numerical visualization tool, we can easily understand complex data. Okay? What is the most frequent word or the related word, or nowadays the related word is very important in the Google search or the web search. Okay? This is one of the interesting video. Can you clearly see? Actually, this is the old, very old. It's